Today we are doing arithmetic sequences, and the definition of that is a list of numbers in which each term is found by adding a fixed number. So, a list of numbers in which each term is found by adding a fixed number. All right, the first one has been done for you. So this is an example of an arithmetic sequence. What is it doing every time? Good. It's going up by 5. That is called the common difference. So like the difference between 5 and 10 is 5. The difference between 10 and 15 is 5. Okay, so it's going up by 5. The starting value is your y-intercept, which means that they use this term, a sub 0. So let me explain what that means. 5 is your first term. Let me use a different color. 5 is your first term, 10 is your second term, and 15 is your third term. To find a sub 0, you have to go back a spot. 5 is your first term. We need to go backwards and figure out what would be in the very beginning before that. 0, because what are you doing every time? You're adding 5. So to go backwards, you would take away 5. So this one starts at 0. This is called a now next rule, and they always start like this. Next equals now plus 5, starting at 0. So here's how this makes sense. If you start at 0, if that's what you have right now, what is 0 plus 5? 5. That gives you 5. Then if you plug in 5, 5 plus 5 is 10. It gives you the next one, and so on. Okay? All right. Then you have what's called the explicit formula, which is just the linear equation. If it's going up by 5 is your slope. All right, 5 is your slope because it's going up by 5. It's increasing by 5 every time. And then the y-intercept was what on this one? 0. So there is a imaginary plus 0 there. Another way they sometimes write it is a of n equals 5n. What's the only difference? They've used a n instead of a x, okay? Now, this is the one that students have trouble with just because it's so weird. This is called the recursive formula. A sub n equals, go ahead and fill this in. A sub n. For this formula, you do a sub 1. A sub 1 refers to the first term. A sub 1 refers to the first term. So if we go look at our list, what was the first term? 5. 0 is called the starting one. So the first term is actually 5. So we put a 5. And this is the formula, but I don't know why they put the D in the back, because on the answer choices, they're always going to put it in the front. So it started at 5, and then what was it going up by? 5s. And then they'll always leave n minus 1 like that. So that's what it'll look like as far as like an answer choice. And we'll do more practice and it'll make a little bit more sense. But one way I remember this one is that there's a 1 here. Do y'all see the 1 here? So this is the a sub 1 that goes there. There's a 1 there. So if you see these as your answer choices, this needs to be the a sub 1, the first term that goes there. Okay? Let's do another one. What is this one doing every time? Good. It's going down by 7, which means the common difference is going to be negative 7. It's going down by 7. 74 is the first term, 67 is the second, 60 is the third. I want the a sub 0, the 0 term. So I need to go backwards. I need to go back a spot. Well, if all these are subtracting 7 to go backwards, you would need to add 7. 74 plus 7 is 81. Okay. All right. Then you write next equals now. That's how they always start. This would be like a multiple choice. Next equals now. It was subtracting 7. And it's starting at this number, 81. Okay, starting at 81. Questions? All right, let's make the y equals first. Make the y equals. So we're starting at 81. We're starting at 81, and we're going down by 7 every time. That's why the 7 gets an X. If you go back and look, how often did I subtract 7? Every time. So it's 7 every time, 7x. Now, sometimes they also write it like this, where they just use an N instead of an X. They're just trying to make things complicated, okay? But it's the same numbers. Now, if your multiple choice answers have N minus 1 in them, if they have N minus 1, you have to use the first term. So go back and look at your list. Which one was the first term? 74. So this one's going to have a 74 instead of an 81. It's going to have a 74, and then it's still going to be minus 7. And they're going to do a sub n in the front. And I know, it's like y, but we have to do it. What? Like how? Yes, you could also, yes, yep. But you have to, on this one, you have to have n minus 1 in parentheses, and on this one, you would just have an x with it. But yes, you could write it in the opposite order. Yep. Okay, number 3, what's it doing? Adding 7, so that would be positive 7. Okay. What's my starting value? 0, good. You have to go back a spot for that. So it starts at 0. Next equals now. What's happening? Plus 7. You're adding 7 each time. And you're starting at 0. Starting at 0. Okay. All right, so for my y equals, you're starting at 0, so I'm not even going to write it. And then you're adding 7 every time. You're adding 7 every time. That's your slope. It's going up by 7, up by 7, up by 7. Okay? All right, then the other way, they might just replace the x with a n. Okay? All right, a sub n. All right, so I'm not going to use the 0 this time. If you go back up and look at the formula, you have to use a sub 1. That means the first term. All right, so let's look. What's the first term? 7. 7's the first term. And then plus 7 every time. Plus 7 every time. Questions? All right, number 4, what's it doing? Adding 8. So the common difference is 8. All right, go back a spot. What would be right here? 1, because 1 plus 8 is 9. So this is a 1. Okay. All right, next equals now. Plus 8, starting at 1. Next equals now, plus 8, starting at 1. All right, so y equals 1 plus 8x. What's the other way you could write that? Well, no, sorry. Like, what other order could you write that in? 8x plus 1, okay? All right, a of n equals 1 plus 8n. All right, anybody want to try this last one? Go ahead, Sean.
Was that for number 4?
Yep.
A
n minus 1. Yep, good. So this is your a sub 1 term. It's your first term in the list. Okay. All right, on number 5, you got to be careful. If I'm going from negative 66 to negative 70 to negative 74, think about a number line. If I'm at negative 66, and I go to negative 70, am I going down or up? I'm going down. Negative 66 to negative 70, you're going down. You're going down by 4. You're going down by 4 on that one. Okay? All right, what would be your starting value, your original term? Negative what? 62, good. Okay. Next equals now minus 4, starting at negative 62. All right, y equals what?
Negative 62 minus 4x.
Mm-hmm. All right, and then for this one, it's not going to be negative 62. What's it going to be? Negative 66 minus 4n minus 1. All right, number 6. It's going by 6 every time. What's your a sub 0? 42. All right, next equals now minus 6, starting at 42. All right, y equals 42, that's your starting value, minus 6x. And then for the last one, it's not going to be 42, 36 minus 6 n minus 1. Questions? Okay, number 7, find the 20th term in the arithmetic sequence 4, 7, 10, 13. Not yet. All right, for number 7, step 1 is to write the y equals. So write that down, please. Write down the step so that way when you're doing your homework, you can look back at your notes. What a novel idea. And see how we did this one. So for step 1, you're going to write the y equals formula for these numbers. Okay? All right, so let's do that. So for the y equals, I don't start at 4. I have to go back. So what would be the number? 1. Okay? So for the y equals, it's going to start at 1. And then what's my slope? What's it doing every time? It's adding 3. Okay? It's adding 3. So that's step 1, to write the y equals. Step 2 is to plug in for x. All right? Step 2 is to plug in for x. So, what do you think we're going to plug in for x? 20. Very good. So, we're trying to find the 20th term. So, I'm going to do 1 plus 3. Instead of writing x, I write 20. The x disappears. The x disappears. I put a 20 in. All right, what's 3 times 20?
60.
Plus 1?
61.
61. That's your answer. Now, if you completely forgot how to do this on the test, to find the 20th term, what else could you do?
Write it out.
You could write it out. 4, 7, 10, 13, 16, 19, 22. All right, you could write it out. All right, number 8, find the 15th term. What's my first step? Write the y equals. Okay, write the y equals. Okay. Does it start at 18? No, you have to go back a spot. Okay, starts at 12 because you're adding 6, so you would have to subtract 6, okay? And then you're adding 6 every time, okay?
Also, to define a 20th term, can you do
Yep. So what am I going to be plugging in for x this time? 15. So 12 plus 6 parentheses 15. All right. You may use a calculator today if you don't have one. 15 times 6 is 90. And then you have to add the 12, which gives you 102. Okay. All right. Number 9. The function a of n equals 3n minus 7 represents the value of the nth term in a sequence. What is the sum of the first and fifth term of the sequence? What's a word I should circle? Sum. And look, Mrs. Williams wouldn't take off any points on my homework if I did that. Sum means to add, okay? All right. Now, guys, there's a couple ways you can do this. You can plug in 1 and 5 for n. If you prefer to go ahead and write this, y equals 3x minus 7, and mark that out if that makes you feel better, you're welcome to do that. This is the same thing as 3x minus 7. Okay, y equals 3x minus 7. I need to find the first term, and I need to find the fifth, okay? So let's find the first term first. So I'm plugging in a 1. 3 times 1 is 3 minus 7 is -4. All right, after you plug in the 1, you need to plug in a 5. 3 times 5 minus 7. So I'm plugging in for the x. 3 times 5 is, minus 7 is 8. Am I done? No. What do you have to do with those? Add them, which gives you 4. Okay. All right, flip it over. And go ahead, for some reason when I did this, I deleted the D. Let's go ahead and write that in. F of n equals 3n plus 12. If a teacher ever tells you to add an answer when you're taking a test, what does that mean? It's got to be the right answer, because otherwise why would they tell you to add it, right? All right, but let's talk about this. So 15, 18, 21, 24, what's happening? All right, you're adding 3 every time. Do you see that? You're adding 3 every time. So the 3 gets a x or an n, okay? Is 15 your starting value?
No.
15 is called your first term. Your starting value, you have to go back. So instead of being 15, it would be 12. So do you see why the answer is D? Your starting value is 12, and you're adding 3 every time? Okay. All right, number 11. Which sequence uses the algebraic expression 3n minus 2? So you have these as your answer choices. Bless you. This is your first term, all right? This is your first term. What is the next one? Your second term, and so forth, okay? To find the first term, what do you plug in for n? To find the first term, you plug in 1. This is the nth term. Let's go back and look at the sheet right before we just did, okay? We wanted to find the 20th term, right? What did we plug in for x? 20. If I want to find the first term, what do I plug in for the variable? 1. 3 times 1 minus 2. What is that going to give you? 1. So you can mark out A and B. The first term is 1. Now let's find the next term. What do we plug in? 2. 3 times 2 minus 2. What does that give you? 3 times 2 minus 2 is? So the answer is C. See you after lunch.